The periodic table is chock full of information, and it's hard to absorb all at once. For right now, what are the important things? This course will mainly be about the main group. So here's the periodic table. And the main group are these two columns over here. It's not this stuff. And then these 6 columns over here. 1, 2, 3, 4, 5. Okay, so that's the main group. And things you should know about the main group. You should know the names of some of these columns. The first column is the alkali metals. So all the elements in the first column are called the alkali metals. The second column are the alkaline earths. Then we have over here the last column, which is the 18th column, which are the noble gases. The 17th column, which are the halogens. And I think right now, just one more column you should know about, the 16th column, which are the chalcogens. And what should you know about these columns? The noble gases, the 18th column, are the column that make it's the hardest to make compounds. They're the most perfect elements in many ways, and they really it's hard to get them to add or subtract electrons. So 0 electrons are added or subtracted to them. The alkali metals in the first column, if they can lose 1 electron, that will put them at the very beginning, and that's something desirable. So the alkali metals like to lose 1 electron. When they lose 1 electron, they go to +1. +1 charge, they've lost an electron. Minus an electron. The alkaline earths, being in the second column, like to lose 2 electrons, and that makes them +2. The 17th column, put in chat what you think happens. They want to get to the end, like the noble gases. Should they add or subtract electrons? Put it in chat. Put in chat. Good. They like to add electrons, so they're going to be a -1 charge, and that's because they added an electron. And the chalcogens want to add 2 electrons. And so that's the natural periodic tendency of the various columns. And one more thing. On the left side, when you go down, let me use this color here. As you go down, the elements get more reactive. So the further down you go, the more reactive you are. And on the right side, by contrast, the more, as you go up in the column, they become more reactive. Okay, so that's the organization of the periodic table. And now let's look at a simple reaction that might happen. I guess a good reaction to take is sodium. So sodium, if you look on the periodic table, is an alkali metal. Put in chat what it wants to do. Yeah, put in chat what it wants to do. It wants to lose an electron. So 2 sodiums go to 2 sodium pluses, plus 2 electrons. They've each lost an electron. Chlorine is a molecule. It's Cl2, so there's 2 chlorines together. And put into chat what 2 chlorines want to do. Let's wait till the you put it in chat while we wait for this whole the computer to put the stuff onto the screen. What do two chlorines want to do? They're in the halogen series. They want to, do you have it in chat? They want to gain an electron. So, oops. So they want to add 2 electrons to go to 2 Cl minuses. And what's going to happen is if you put sodium together with chlorine, then the sodium will give up its 2 electrons, the 2 sodiums, so the 2 chlorines can accept the 2 electrons. And now what we're going to have left over is 2 Na pluses plus 2 Cl minuses. And plus charges are attracted to minus charges. And so there's another kind of force law. I gave you an force law for electric fields, but you have just 2 charges, Then the force, the electrostatic force, is quite simple. It's attractive. Opposite charges attract. And it's the charge of, in this case, the sodium plus times the charge of the Cl minus divided by the distance squared. So here's my sodium plus. Here's my Cl minus. And we take the distance between the nuclei. And that's R. And this is a much simpler equation when you have just 2 charges. That's much simpler to use than the electric field. So in this case, sodium and chlorine are opposite signs. They attract, and when they attract, they make 2 NaCl. And do you know what NaCl is? Put it in chat if you know what it is. NaCl is table salt. It's a solid. We write the form of the matter, solid, and that's an example of a reaction and why it occurs due to where sodium and chlorine are on the periodic table.